Hey there everybody, welcome back to my YouTube channel. So I know I say every video is exciting, but ooh, I am excited for this one. I can't even tell you guys. So I do TikTok lives quite a lot. For those of you who don't know, many of you probably found my YouTube through TikTok, so maybe you do know. So I do lives on TikTok, I try to do them maybe like 4 or 5 times a week when I can. So I always, though, will have some people arguing with me in the comments on the lives that I am mathematically wrong. Like, they will actually just flat out be like, nope, that's wrong. You're wrong. You don't know what you're saying. So look, I don't know if they're just trying to, be haters or if they genuinely think that they are mathematically correct, but they were not. So today we're going to be doing basically a bunch of questions that people have argued with me over on TikTok lives, telling me that I am mathematically wrong. We'll talk about what they said and why they're wrong. So if you're excited for this video to spill some tea, learn a little math along the way, or a lot of math rather along the way, let's jump into today's video. So the first thing I have to point out actually before we do question 16 is I actually titled this document Questions that people have fought with me over. Really creative title, I know. Bonus points to me. So let's start with question 16 here from practice test 10. So they tell us that in 2015, the populations of city X and city Y were equal. Okay, so let's just write that. So we know that in 2015, city X was equal to city Y. We know that this is in terms of the population. I'm not going to specify that. So from 2010 to 2015, it says right here, the population of city X increased by 20%. All right, so let's just go ahead and write that down. So from 2010 to 2015, we know that the population of city X increased by 20%. So whenever we're expressing a percent increase, here's how we're going to go ahead and do that. So a percent increase is modeled by adding whatever the percent increase was to 100%. So here we would have 100% plus the 20% increase, which would give us 120%. All right, so we know that it's 120% for city X. So let's just write that for city X right here. And then they tell us afterwards the population of city Y decreased by 10% over that same time period. So let's do city Y in purple. So from 2010 to 2015, we're talking about city Y. So here we're talking about a percent decrease. So what we do to model a percent decrease is we take 100% and we subtract the percent. So here we're going to do 100% minus 10% is going to give us 90% overall. All right, so now that we have this all modeled out, they tell us right here in the question, if the population of city X was 120,000 in 2010, what was the population of city Y in 2010? All right, so we can go ahead and find out what the population of city X is in 2015 because we know that it increased by 20% over those 5 years. So if we take the population in 2010 for city X, which was 120,000, so that's the initial population, and we multiply it by 120%, which is a decimal. Whenever we're trying to convert a percent to a decimal, all that we do is we take the decimal place and move it 2 places to the left. So that gives us 1.2 that we have reflected right here. And 120,000, let me grab my calculator, times 1.2. Pretty good at mental math, but I don't know if I can do that in my head. That gives us that the population of city X was 144,000 in 2015. All right, so far so good. So we know that the population, though, of city X and city Y were equal in 2015. So I know then that the population of city Y, so city Y was 144,000 in 2015. So we know that from 2010 to 2015, the population decreased though by 10%. So what that means then is that we want to find out what our initial population is. Let's call that, maybe we don't want to call that X because they called them city X and city Y. I don't know why they did that. Let's just call it A. So A is going to represent our initial population in 2010. So we know that A times 0.90, again, that's 90% written as a decimal, is going to be equal to 144,000. So basically, after it's going to decrease by 10%, 144,000 is the result. So that means then that we need to start with a higher number, because when it decreases by 10%, that results in 144,000. So on my TikTok live, everyone's like, no, you got to multiply 144,000 by 0.9. And I'm like, that doesn't make sense, because then you end up with an initial population that's lower, but that doesn't make sense because it says that it decreases over time. So no, you're going to divide both sides by 0.9 here. So we're going to divide both sides by 0.90. That's going to give us a bigger answer. So we're going to get that the initial population of city Y is, divide that by 0.9, 160,000 as the final answer, which gives us choice C. Alrighty, looking at the next question. Ooh, this one is probably the one I get the most. There are multiple varieties of this type of question, but this one is definitely one that I get so many people arguing over, because they don't know the difference between when you have a square root as part of the problem versus when you introduce a square root to the problem. So I've had people say, oh, I'm a math teacher, this is wrong. I'm like, well, I don't know what to tell you, because it's actually right. You could go ahead and look at the College Board answer key and you could go argue with them, because it's actually correct. So let's talk about the difference. So the square root of 25 is very different from x squared is equal to 25. So when you have x squared is equal to 25, in order to solve this, you're going to have to take the square root of both sides. When you introduce a square root as a way of solving the problem, that's when you have both a positive and a negative solution. So that's when you're going to get here that x is equal to plus or minus 5, which means that x can equal positive 5 or x can equal negative 5. However, when the square root is actually part of the problem, like you didn't put it there, it already came factored in. You just take the positive version, which means that the square root of 25 is just positive 5, no negative 5 included. So it's a really important distinction, which is why these questions actually appear towards the harder questions of the test, because they know that you're probably going to make that mistake and argue with Jackie on a TikTok live as well, because why not? All right, so they ask us, what is the set of all solutions to this equation? So when they give you choices, plug them in. Don't be smart. Don't try to square both sides and create a quadratic that you need to solve. Just plug in the choices. So like we said, we're talking about how whenever the square root is part of the equation, this side right here has got to be equal to a positive number. So this side must be positive. So automatically, when I plug in, let's say we plug in negative 1. So we're going to be plugging in negative 1. So let's start with that in choices A and B. And if we plug in negative 1 into something that's already negative, that's actually going to make this side equal to positive 1. So positive 1 so far looks okay. However, if we plug in 2, let's go ahead and do that. That would give us negative 2, which is equal to a negative number, so that would not be okay. So anything that has a 2 is not going to work. So now let's actually try plugging in negative 1 on both sides and seeing if the two sides are equal to each other. So we would get negative 1 plus 2 is equal to negative 1. So negative 1 plus 2 is the square root of 1 is equal to 1, and that is true. 1 equals 1, so it's got to then be choice B. So all you got to remember for this question, plug in the choices if they provide them. That's the easiest way to do it. And remember that if the square root is already written into the problem, it needs to equal a positive number on the other side of the equation. Alrighty, then let's check out this question from practice test 3. So they give us a table here. Function f is a polynomial. Some values are shown. Which of the following is a factor of f of x? So let's just do a little background here. So a factor of f of x. So you might have seen, I don't know, I'm going to make up a quadratic. Y is equal to x squared plus 5x plus 4. So when you go ahead and factor this, when you're trying to find the solutions to this quadratic, what you're going to do is set it equal to 0, and then you're going to have to factor it. So when we factor it, we're looking for two numbers that are going to add to positive 5 and multiply to positive 4. So the only two numbers that would do that would be positive 4 and positive 1, because 4 plus 1 gives us 5, and 4 times 1 multiplies to 4. And then what you do is you set each of these individual factors equal to 0. So x plus 4 equals 0. That gives us x equals negative 4. And x plus 1 equals 0. So that gives us x equals negative 1. So first thing that you want to notice is that we're able to get the roots when y is equal to 0. So when y is equal to 0, f of x is just the function notation, a fancy way of saying y. So when we're looking for the factors and the solutions, y or f of x needs to be equal to 0, which means we're looking at this column right here. I've had people argue with me that it's actually, you should be looking, don't write this down because it's not correct, that you should be looking at this first column here when x is equal to 0. But that's not true. We're trying to find the value of x when y is equal to 0. We're looking for where it hits the x-axis. Like when we're talking about solutions, I'm just going to make up a random graph here. These right here are what we're talking about, the x-intercepts, the solutions. Okay, so this is what we're looking at right here. So we can see that x is equal to 4 when y is equal to 0. However, if you notice, the factor and the root are always of opposite signs. So if the root is x equals negative 4, the factor is x plus 4. So if the root is x equals 4, the factor would be x minus 4, flip the sign, which makes it equal to choice C. All right, and another question, again, from my own workbook. People argue with me about exponent rules quite a lot. I don't know. So what people argued with me about, I'm going to write something down that's wrong. I'm going to write wrong so you guys don't like get this, wrong on the test. So what they'll tell me, I first just want to look at this x squared to the third. They'll tell me that this is equal to 5, but that is not true. I think what they're trying to think is that you add these two together, but you would be doing that if it were x to the second times x to the third, because then you would add up the exponents. That would give you x to the fifth. So this is for multiplying, but this right here is not multiplication. This right here is the power rule. So whenever you're raising an exponent to a power, you don't add them, you actually multiply them together. So this is all wrong, so let me go ahead and erase that before we get that ingrained into anybody's head right here. So what you actually want to do is for the power rule, you multiply the exponent by whatever it's being raised to. So x squared to the third is going to be x to the 2 times 3, so it's actually x to the 6th. And then on the outside, we have another x, so it's times x to the 1. So now that these two are being multiplied together, you add their exponents, which gives you x to the 7th. So x to the 7th equals x to the a. So we know then that a has got to be equal to 7, which gives us choice C. Alrighty guys, thanks so much for joining me for today's video. Hopefully you learned a lot about math and also laughed a little bit about what I have to deal with on my TikTok lives almost every single day. So if you want to argue with me on a TikTok live, your question too could end up in one of these videos. I'm totally just kidding, guys. Thanks so much again for joining me today. Follow me on my TikTok, testprep tips. That's the username. We'll drop that somewhere over here. Also, all of our upcoming crash course registration links, those are all linked in the description, as well as the link for our SAT math workbook. I featured 2 questions from that in this video. It's called No BS SAT Math. You can just directly get it from Amazon in the description below. Thanks so much, guys. Take care. Have a good one.